Hi everyone, I am going to teaching to you electromagnetic field subject. Electromagnetic fields. Yes, we are studying electrical engineering. Right? First of all, we are studying engineering. After that, we can say which branch we are going to study. The engineering is nothing but it is an application of mathematical rules and scientific formulas to the practical ends is called engineering. In that, in electrical engineering, a branch of engineering science which deals with generation, transmission, and utilization of electrical power or energy to the various consumers is called electrical engineering. Now come to the definition of electromagnetic field. It is a branch of electrical engineering. It is a branch of electrical engineering. Branch of electrical engineering which deals the interaction or interplay between electric field and magnetic field. It shows the interplay between electric field and magnetic field is nothing but electromagnetic field. The study of this interaction between electric field and magnetic field. Electric field we define with letter ER because electric field is a vector quantity. Why? Because if anywhere electric field is there, voltage source is there, we can append polarities, which is positive which is negative, and magnetic also reference. That's why electric field, electric voltage source is a vector quantity. Similarly, magnetic source, magnetic field intensity also vector quantity. Now the interplay between these two, we are going to study in this electromagnetic field subject. So before entering into this subject, we have to know some basic definitions related to this subject. Some basic definitions. The first definition is charge. Charge is a fundamental quantity. It is a fundamental quantity. When you already know charge either creates nor destroys. One form of charge also called neutral. If the person is at a handful means he is not having any energy, he can't do any work. If he is eaten any food means he was charged, the person is charged. Next he can do the work. So without taking food, he can't do the work. So any particle initially it is a neutral we can say. And this charge, from this charge creates, it will create some charge characteristic. Charge creates electric field. And charge it also can causes magnetic field. And the charge can causes electromagnetic fields. Charge can cause electric field, charge can cause magnetic field, charge can cause electromagnetic field. About these I can explain with three cases. With the three cases I can explain. In case 1, if charge is at rest, means its charge is not moving. Charge is not moving. That is, charge is not moving. Say at any one particular point, if charge is there, a person, the body is charged. Say positive charge, body is charged. So that body this is the body. This body is charged. Now that effect is at certain distances. So assume in this region that effect is region, up to this region, that effect is there. Maybe at this location, at this location. At anywhere you take only one test point. Such the test point as QT. Means the charge effect is there up to at this test point. Means if charge is stationary, means it creates only electric field. Charge is not moving, charge is stationary. That is, it charge at stationary, it creates only electric field. You may get doubt, electric field development means which direction is developing. So if any body is charged, throughout this entire, I have food, I can do the works in all the directions. Similarly, a body is charged means it will dissipate the charge in all the directions. In all the directions, mathematically, we represent with three-dimensional view. 3D. In one direction, I can do in only one direction. That we define with line. If I do the work in two directions, that we define with the x-axis, then y-axis. If I can do the works in all the directions, we define with three-dimensional x, y, z axis. Like this, mathematical tools we are going to using. So all the directions means in three dimensions. Means this charge is what it is creating electric field. Electric field we define with the letter E. So it is x, y, z, and it is independent of time. This charge, if at rest electric field is existing, the electric field is independent of time. Why? Because I have energy without doing, my energy will be there if I assume ideal case. No losses means my weight is I have energy. That energy I am ready to apply. So that apply energy, it is independent of the time. Anytime I can do the same work if there is no loss. Next, and this electric field it depends on medium. Medium means in the air, certain heat, certain electric field intensity will exist. If you any place with certain some direct strength materials like insulating materials, through that flowing electric field is different. So you can say electric field is independent of the time. See from this expression here, electric field intensity, the force existed by the test charge. Thus electric field intensity, force existed at test charge. See from this also we define electric field intensity E bar is equal to force divided by test charge, that QT. So that QT will be extended limit from QT tends to 0. Why QT tends to 0? Because charge we are going to considering at allow only. With this charge only we are going to consider means limit QT tends to 0. If any other bodies means that is different. We can represent the limit. So QT tends to 0. This is the expression for electric field intensity. From this what the units we can say force units are newtons, charge units are coulombs. So newtons per coulombs. Newton per coulomb is the electric field intensity units. These are in mechanical. If you represent it in electric field, every voltage source units are what? Volts divided by. So how much distance the electric field is, if that electric field effect is there, how much distance? Generally, it will be in measure. It is impossible in kilometers. Generally, it is in meters, millimeters, centimeters, like that. That's why depends on the voltage rating. Of transmission line between the conductor to other part, any other conducting material, we are going to provide with certain spacing. If voltage increasing, means we are going to increase the more space. Why? Because the electric field intensity will be up to certain distance around the conductor. So electric field intensity units also can be defined with the units as volts per meter. It is a vector quantity. Means here the existed electric field charge at rest. What I can say here? Charge static electric field. Static electric field. The study of these static electric fields, is called electrostatics. Electrostatics means in this electrostatics topics we are going to study about only stationary electric field. It means if there is a charge is rest, then we are going to see. And this electric field depends on this static electric field. This static electric field depends on medium. I said already, the static electric field depends on medium and is independent of time. This is about static electric field. It charges at rest. Next, in case 2. If charge moving with uniform velocity, charge is moving there with uniform velocity. Uniform velocity is nothing but with the constant speed. How we define uniform velocity with the physics? Equal distance, it covers equal distances in equal intervals of time. Means at 1 hour, if charge is traveled for 100 kilometers, means next 1 hour also it has to travel 100 kilometers. Next 1 hour also it has to travel 100 kilometers. Means you can say here charge is moving with constant speed here. Charge is moving with constant speed. Whenever current is flowing in a conductor, if anyway, whenever current is flowing in a conductor, whenever current is flowing in a conductor, any current carrying conductor is nothing but what? It is a magnet. To increase the magnetism, we provide any magnetic material like iron disc, silicon, steel material, anything to increase the magnetism only. Every current carrying conductor is a magnet. So whenever current flowing through the conductor, it creates magnetic field. So those currents are moving what direction with what velocity? Constant speed. So because of this constant speed, constant magnetic field will develop. Means here currents are stationary, conductor is stationary, constant currents are flowing. Here the existing magnetic fields are called static magnetic fields. The study of these static magnetic fields is nothing but magnetostatic fields. With magnetostatic fields topics, we will study about magnetic fields which are moving with constant velocity. So generally, if any conductor is carrying current, what I am saying, the surround flux will travel. Say this is the one conductor, straight conductor carrying current of 5. So once currents are carrying straight conductor means surround the conductor, magnetic field lines will travel. To identify the flux direction, we use right hand thumb rule. In that right hand thumb rule, for straight conductor, we represent current. For straight current carrying conductor, we represent current direction with thumb. Then the remaining four fingers represents flux directions. Similarly, if you are concentric winding, if you are continuous winding, to that continuous winding, in current direction, we represent with the forefinger. Then thumb indicates north pole polarity. The bottom one indicates the south pole polarity. Already you studied about solenoid concept. With the solenoid concept also same. It is saying preparation of electromagnet, preparation of artificial magnet. What is the purpose of this artificial magnet? To provide a constant flux. Why? Because if you want to prepare electrical energy or voltage source, if you use the permanent magnets, what happens? The electric field intensity is directly proportional to flux. If you provide more flux, you can get the more voltage. Less flux, you can get the less voltage. So the developed electron induced EMF is proportional to rate of change of flux linkages you studied. So with the permanent magnets you can't provide a constant flux. Why? Because with the permanent magnets after certain period flux decreases. If flux decreases, electric field also decreases, voltage source magnet also decreases. But you designed all the loads to work for constant voltage. That's why we have to generate and we have to transfer the constant voltage what loads are required. So based on that, some standards are specified. Government specified standards. Suppose in India, single phase, we need single phase consumers, 230 volts, 50 Hz voltage source. Plus or of course there plus or minus 5% tolerance is adjustable. Plus or minus 5% tolerance is adjustable. So that's the constant voltage. So to get constant voltage, it is not possible with the permanent magnets. That's why we are going to preparing magnetism artificially. That is nothing but electromagnet. Is nothing but electromagnet. How we are going to preparing electromagnet? By taking any one iron piece. By taking any iron piece. If you wounded with wire, if you wounded with wires, and if you connected any one voltage source, say I am connecting here one DC voltage source is nothing but battery. DC voltage source. Why? Because we are not having directly any DC voltage sources. DC voltage, because whenever we are going to having AC voltage sources, whenever if you want to charge the supply, we are going to converting the whenever if you want to store the electrical energy, we are converting AC signal into DC. That DC we are going to store in the battery in the form of chemical energy. Again, if you require the DC, we are going to converting into AC and we are going to utilize the loads if you want. Right? So we can't store AC. We can store DC only. Remember, it is impossible to store because for AC signal, what is the average value? For positive half cycle, if you are getting 100 volts means negative half cycle minus 100. So total becomes 0. So like that, our number of cycles are existing. So average value 0. That's why we can't store DC. We can't store AC. We can store AC signal only. Now here, so from positive terminal to negative terminal, current starts. On the iron piece I placed windings. Remember, again between iron piece to winding some insulation will be provided. That is called varnish paint. Varnish paint insulation will be provided. So that because of the varnish paint, there is no contact between iron piece and the windings. So there is no short circuit. Now, if currents are flowing, what I am saying, if currents are flowing, it behaves as a magnet. Voltage source, if there is a voltage source means we can say which is positive terminal, which is negative terminal. Similarly, if there is a magnet means we can represent which is north pole and which is south pole. So to identify through this concentric winding or any winding, to identify the pole's directions, we use we use right hand thumb rule. To know the voltage source polarities, we use Fleming's right hand rule. To know the magnetic field, flux, magnetomotive force polarities. Magnetomotive force polarities are nothing but north pole, south pole. Voltage source polarities are nothing but positive terminal, negative terminal. So to know the which is north pole, which is south pole, we use Fleming's right hand thumb rule. In that right hand thumb rule for concentric winding, we represent the four fingers. The thumb, other than thumb, we representing four fingers of right hand in the direction of current. Then thumb indicates north pole polarity. See here, all the currents are entering into the iron piece. See, we are going to see front view. We are not going to see back view. So front view, currents are entering, coming out. Currents are entering, coming out. Currents are entering only. You are going to see. So entering only if you are going to see means if you apply right hand thumb rule. This iron part behaves as north pole. This iron part edge behaves as north pole. If it is north pole means bottom one is south. So flux travels from north pole to south pole. Flux travels from north pole to south pole in the air gap. And inside the magnets, flux travels from south pole to north pole. This is called electromagnet. This you studied with solenoid concept. Here I use currents in four fingers of my right hand thumb poles polarity. But here to the side conductor, only one conductor means we can represent here current. We can use in any directions. Here the current direction I am going to represent with thumb. Then the remaining four fingers. Represents the flux direction. So no doubt if currents are flowing means through the conductor. flux lines will travel. In which direction flux travels now here? So if you represent term means this means which direction? Anti-clockwise direction. In this direction flux lines will travel. In the straight conductor in this direction flux lines will travel. If you assume here is a electromagnet, if it is iron piece, so that iron piece behaves as a magnet. Then how you can which is the north pole, which is south pole? You can say that time the flux, the iron piece part which is giving flux to the area, the iron piece part which is giving flux to the area, that behaves as a north pole, and which is taking, see there, it is taking from the area. This is air. This entire surrounding is air. So this part of the iron piece behaves as a south pole. Remember, this part of the iron piece behaves as south pole. Suppose if you want to check if another conductor is there, if there is another conductor, say another conductor is there, and say assume this also current carrying in the same direction. If this also current carrying in the same direction means here say assume some iron piece is there. So between these two. Now here this part behaves as south pole, this part behaves as north pole according to our explanation. It is giving north pole, taking south pole. If any nearby, if any two straight current conductors are there, then between those two attraction forces will exist, we can say. Between those two we can say attraction forces. If any two lines are there, if any two lines are traveling, so if they both are carrying current in the same direction, then we can say attraction forces are there. So that's why transmission line, we are not providing the two lines to carry the current in the same direction at all the times. So three-phase signal is nothing but what? One time, one phase to another phase current will flows. After 1-2 degrees from other phase to other phase, like that between the three conductors current interchange will happen. That's why we can avoid their attraction or repulsion forces. For some period attraction means some force and repulsion. With that we can maintain the balanced system. We can maintain the balance system. Otherwise if always attraction forces are there between the conductors means what happens is mechanical life of the transmission system will decreases. So that's why to avoid attraction repulsion we are going to provide certain spacings. Of course already we are going to provide certain spacing. So distance we are going to not only the distance is not only based on the voltage source magnitude and the distance between the magnetic criteria. Based on magnetic criteria also we can provide the spacing between two conductors. So this is about the electromagnet. If charges are moving with constant speed, so if charges are moving with constant speed, we will get DC current. DC current. That current is called DC current. If charges are moving with constant velocity, DC currents will exist. So here, what we can say here, because of electric field, we are getting magnetic field. But because of magnetic field, we won't get electric field here. Why? Because charges are moving with a constant velocity. So it is electric field is giving magnetic field only, but because of magnetic field, we won't get electric field here. From the magnetic field to get electric field, what are the requirements? We need conductor magnetic field. Anyone has to rotate with respect to space, or anyone has to rotate with respect to time. Time variation means if there is AC currents, then because of magnetic field will come, because of magnetic field electric field will come. That we will see with the case 3. So here what we have to study here electric field and magnetic field. Electric field will depends on magnetic field, but magnetic field is independent of electric field. We can say here both are independent with each other. Independent with each other. We can say in case 1. In case 1. See here magnetic field. Here magnetic field is independent of time. Magnetic field is independent. All the times same flux will traverse if it is carrying the constant current. And here this magnetic field also we define with 3 dimensions: x, y, z. Why? Because magnetic field around the conductor is what total around the conductor in all the direction of the conductor. That's why this magnetic field also we define with the static magnetic field also we define with the 3 dimensions: h of x, y, z. H of x, y, z. Next case, third case. These are called space vectors. This is a vector quantity. This is space vector quantity. Next case 3. charges moving with non-uniform velocity means here acceleration is non-zero. Means charges are moving with different velocity. If charges are moving with different velocity, then charges is moving with respect to time and space, hence time varying and dynamic fields will exist. If charges are moving with respect to space and time, the existing fields are called time varying fields. These are also called dynamic fields. Because of these fields, AC currents will exist. Why? Because if you given any voltage source, AC voltage source to any magnetic circuit, what happens there? Any identities, what happens there? AC flux will travel, AC currents will travel. Because of AC currents, the developed flux are also AC fluxes. One time it may be north pole, one time it will be south pole. Depends on variation of type. So for positive half cycle, if north pole south pole form means, for negative half cycle, polarities will get a reverses. Current direction reverses means magnetic poles polarities also reverses. So the existed AC fluxes will cause the stationary conductor. Again there electromagnetic fields will exist. That's why you can say here, because of electric field, magnetic field will exist, and because of magnetic field, electric field will exist. That's why here you can say both the fields are interdependent with each other. Electric field and magnetic field both are interdependent with each other. So electric field we can define here space vector as x, y, z, and this depends on time here. It depends on time. Similarly, magnetic field also defined with all the three dimensional. It depends on time. So interdependency, the interrelation between electric field and magnetic field is explained by the scientist Faraday. The scientist has explained the interrelation between electric field and magnetic field. This is about the concept of charge. Next, with this knowledge, we study about the electromagnetic model. Electromagnetic model. See, this electromagnetic model, total what we are going to study with electromagnetic fields. About here, in this subject, we are going to study about electric field intensity, electric flux, magnetic field intensity, and magnetic flux. Electric field intensity, magnetic flux, electric field intensity, electric flux density, and magnetic flux density. About these we are going to study in electromagnetic model. Electric field intensity, electric flux density, magnetic field intensity, magnetic flux density. So let us see about electric field intensity. It is a vector quantity denoted by letter E bar. It is a measure of strength of electric field at any point means if any body is charged, electric field is there, that body effect on any particular point, how much amount of energy will be there, because how much amount of that effect is there. So that will be explained by the electric field intensity. That will be explained by the electric field intensity. So electric field intensity already we discussed today, right? So electric field intensity, how you define? If you take any one particular charged body. If it is a Q means that effect